Cthulhu Lover. All right. How's everybody doing? It's been a long week. Lots of stuff to do. Lots of pressure.
Frankly, my dear, I don't give a damn.
All right, getting set up here. I was a little unprepared. Not unprepared, just I was in the middle of testing some stuff and got obsessed. Kill a couple things that shouldn't be running. All right. And that music's maybe a little loud, even though it's good for me. All right, that's better, I think. All right, so where do we leave things? We were working on the DX12 backend stuff, and we got a good first PR, but there was issues running it on the. Here, let me bring this in. Let's start sharing my screen and do stuff here. Hey, Aristotle. Window. Nope. Entire screen. All right. Yay, entire screen. All right. Everything good there? Yep. All right. So, yeah, so last time we were working on the DX12 implementation because we had issues there. That's the last hurdle to getting 385 out the door, which was supposed to be out the door months ago and last month, and now finally I think we're at the end of this. It was failing the unit test only on the unit test runner, which it looks like it was a resource level issue. One of the devs that works with MonoGame right here. I'm never going to say that name right. Anyways, this guy, or gal, or person, they, in New Jersey. Okay, cool. They did a bunch of fixes in their own PR off of mine, and we reviewed them. Things look good. There's some real basic, simple things that he found that were wrong. And in essence, what it ended up doing was it ended up meaning that the samples or the unit tests were using too much memory. And the second the unit test used too much memory, it was crashing out. And that was because the unit test runner is not a super high-end machine or anything, which it doesn't need to be, So the fact that is Cthulhu over in chat. Okay, that's right. I forgot about that. Sorry, when you use different names in different places, it makes it confusing. I have the same problem with other devs. But yeah, so that was basically what was causing most of the issues, or all the issues essentially, was resource limitations. And you can kind of see it in the pull request, like how we got to there. So all the unit tests passed. There's a merge block there. I just noticed, so I need to see what that is. Let's see. I work all my Git from command line because this is how I work. For the latest. Oh no. Need to fetch upstream. I could have done this from the PR, but I didn't want to. Oh, it is up to date. Why is it having a problem then? Pretty sure that goes on. Okay, that's interesting. Oh, review required. That's the problem. All right. Somebody want to review the PR? I mean, it's not a problem at the moment. We're gonna do a couple more fixes before we actually merge it. But this is all great. So, yeah, sorry, I misunderstood that. So okay, so it's actually fine. had some local changes that I was still messing with. All right, so let's get back to this. The good news is that performance is looking great. I had to do a couple more fixes, but performance is looking great now. Hang on, let's just run it on here. This is, music pause for a second there in a weird way. So if we run it in Vulkan, we'll run it in DX11 to start with. That's nice that we can do that. That I can run it on DX11, compare it to our performance on. This is a debug build. Let's just run it to release, just because that'll be more interesting. All right. All right. So if I show my frame rate here, it's locked at 60. I take off VSync. You know, you can see it's pretty low, but let's actually get into the gameplay and look there. And we'll load the same scene we have been testing on. You can see here it's running, you know, a millisecond of draw time, a little over a millisecond of draw time. That's actually the draw function. You know, the update time it should be the same for all of them because it's the same code. And then the frame time's like 13 milliseconds, something like that is what it shows here. So nothing too bad. So then let's go look at desktop BK, also test release. I'm running with debugger attached, probably slowing it down a little bit, but who cares, as long as they're comparing the same thing. I mean, there are definitely things we still can do to improve the performance further, both, you know, at the low level runtime and the game itself. But right now, I just want to see that this is working appropriately. This startup time on Vulkan, we might look at that. That is horrendous. It takes forever to start up, and I think it's because of how we set up the texture copy on Vulkan. It is killing us. So here, you know, our draw time is a little higher, 2 milliseconds, so a little bit more CPU time being used in drawing. Frame time includes the present, which is the block, and that's it's a little higher. It's at like 17. So the frame rate's a little lower here on Vulkan. Oh, sorry, wait, what? Is that? I guess it just looks very similar. It's running slow enough that the performance, that's interesting. VSync off. Why doesn't it not feel like, I need a more clear case here, just for shits and giggles, yeah. Because it was close enough that it made it feel like, you know, VSync on and off was doing nothing different, but it's clearly doing something different. So at this point, it seems that Vulkan is a little slower than DX11, which sort of makes sense. I can't say that our Vulkan implementation is fantastic or anything, but it works. So that's a positive when we have some stuff. That's actually a bug, and that's one of the things we need to look at. It's not major for the 3.8.5 release, but there's obviously something going wrong there, causing that to pop out when it shouldn't. So something to investigate there. I'm sure it's a resource thing of some sort. You can see it happening here too. So there's something going on. So testing this is probably not, you know, super honest, and that it doesn't work properly. So now let's look at DX12. And the fixes we've done have definitely improved things massively. Come on, code, build. These are all the same window size on the same machine, same GPU. So there's our frame rate. There's VSync off. So about the same draw time as Vulkan, maybe a little slower The frame time looks to be a little faster. It looks closer to 13, where Vulkan was like 15 or 16. But overall, not too dissimilar. We'd have to do some real, we'd have to improve that a little bit more and add some real metrics here to verify that, it's working equivalently. But it's pretty damn close. All these things are, little details we have to work out. You can see things here more stable. All our rendering isn't flickering in and out, so our states are good. There are probably definitely things we can do better than what we are. That room looks nice for some reason. I still have a bunch of broken textures in these scenes. We've not been focused on the environment stuff over the last couple of weeks. We've been mostly focused on just getting DX12 out the door. So yeah, so overall our performance is pretty freaking great. And this scene is doing some really horrible things. Like this room we're in is several million polygons by itself, which is bad news. It shouldn't be that heavy, but it is. If it wasn't that heavy, it wouldn't be performing as badly as it is. But yeah, I'm pretty happy with our results here. It gives us a good DX12 implementation that should extend to everything else we do. So let's double check things here. So this is working pretty good. I'm happy with it. There are a couple things we want to probably look at that came up kind of in a discussion of our implementation here. One thing that I had done, so one thing I was looking at, and I have an implementation that I have in another code base I should probably bring across. But I look to remove and I might do this on another stream, off the stream anyways, since I can't really show that other code base while I'm on stream. One thing I had looked at was removing, I hate that style. Like currently we manage the command list and the allocator as separate, we manage them separately, which I guess the idea is that, you can use the same command list with several different allocators, and because the allocator is really the thing that has to stay alive while the rendering is going on. Like you can use the command list and just attach it to a new allocator. That said, it seems like it just makes all this code so much more complicated. You're managing two different lists and you're doing multiple things to kind of get yourself a new command list. It's kind of doing, it's basically trying to manage two separate things instead of just managing one. So one implementation I had simplified this to just keep the context, the command list and the allocator together. It just keeps them together. Yes, it means you're making more command lists than you technically need, but I don't believe that a command list has very much overhead. And I don't think there is a massive win to, reusing a command list. Let's see. See how Google's search is telling us. Okay, so yeah, that's what I figured. So yeah, I don't think there's any real benefit to managing the command list separately from the allocator. It is maybe a super minor benefit. So yeah, I might drop that out and replace it with something that's simpler. I mean, this came out of most of this code. I mean, this code was contributed by somebody that did a bounty for us originally, but the code came from the, what was it? It came from one of the Microsoft samples. Which one was it? Yeah, Microsoft's mini engine samples were some of the stuff came from, which that's what it's there for. So yeah, that's one thing. There were some other things that I did here that, yeah, this is another case that I think I want to fix. Like this is doing the blocking. Oh, no, this is already fixed, I think. Yeah. Inclusion of MIP levels. A note about breaking Xbox builds. Yeah, I need to look at those things. You're right. I just can't technically do that on stream, really. So, but I will look into that. I'm not going to... Arstertle's mentioning some things that need to be looked at in that PR, and he's right. They do need to be looked at. So it's not really ready to merge. So, yeah. In fact, what I'll do is... Can I switch this back into a draft? I thought I could. Maybe I can't. Yeah. It shouldn't be merged yet. Anyways. But yeah, it needs a review, but it shouldn't be merged. But thanks for reviewing it, Aristotle. So, yeah, what I was thinking of was before... Yeah, I think it's already fixed this. I think at one point we were blocking after this. And it's like, no, it should block before it puts it into the list, and freeze it. So that's better. Anyway, so one of the other issues that we were talking about was just memory usage. This is one thing I'm a little concerned about, bringing them down the preferred block size. That can hurt performance to a certain extent. I know why it was done. Basically, it was to try to reduce the overhead on like the allocator. That's the D3D12 memory allocator system, which is a open source allocator. Because again, you can write your own if you want. It's up to you to manage the memory, not up to the GPU really, or DX12 itself. It doesn't manage memory. You have to use your own allocator. So this is a standard allocator that Microsoft created, I believe, or is it that it's the AMD created this allocator, just sort of similar to the Vulkan memory allocator that people use. When we initialize it, you give it a preferred block size, which is used whenever it creates pages internally to put things in. And the default is 64 megabytes, which means that, and at one time, the repo was, or the implementation was using the default was 64 megabytes, and it was using a ton of memory on the unit test machine. Well, I think with the other fixes that he did here, it's probably okay for it to still be 64-bit or 64 megabytes. But I want to double check some of those things. So let's do a couple things first. One, just for shits and giggles, let's see what kind of, because I think actually, let's check. I'm just gonna run a debug, it's fine performance-wise, I don't care. What I want to see, I think there's a easy way for me to see GPU memory usage here. Just be able to look at it and just get an idea, just differential of memory usage. Oh shit, that's the wrong project. Go away, unit test project. I was trying to test the game. I was wondering why it was taking a while. Well, I think I want to try to stick to 64, but fix the allocations to not use the wrong. I mean, the issue was basically it was allocating every small texture in a 64 megabyte page dedicated to it, and that was killing things, especially in the samples that we allocate a bunch of, like all the unit tests, they use very small textures, so it was allocating a ton of that stuff. Not to mention it was also leaking things. So those didn't help. So just want to see what happens when I load a scene here. I know there's probably better ways to get this measurement, but I'm not interested in dicking around with stuff. So let's just see what it does. Where does it show? Dedicated GPU memory. So at 1.6, I'm going to load the scene to 2.2. You know, as is, it's going to use 2.2. So then the question is, and I'm going to look at that too. There's some memory leaking going on. So not going to go back down. Oh no, I leaked textures. No, that's not what's happening. Something else is using my memory GPU. What is using GPU right now? It could be anything, I guess. Don't have any copies of Unity or anything running, or Godot or anything. So yeah, I'm not sure what's sucking up some GPU there. I guess it's the system itself. Anyways, now I want to go. What is that? Oh no, it's in the. Sorry, my brain's fried. It is in. Oh, where are we? There. Yeah, probably. Windows just randomly deciding to use my GPU because I used it. There, preferred block size. So that was at the 4 megabyte block size. Let's see if we disable that and run it this way, where we end up when we start the level. So 1.1 to 2.1 essentially. It's funny, I just started using more memory the second I just started the thing. So this is going to invalidate my test if it keeps doing that shit. So where were we? Like 2.1 minus. So it's basically using like 1 gigabyte of memory. So 1.7, we'll load this. 2.2. So I mean, didn't really change very much. I didn't see much of a change at all between the two. And it probably is true because it's using much less, because when it allocates textures now, it does not allocate a full page dedicated to every texture like it did before. You know, to validate that, we go back and I like to usually just double check things and make sure things are doing what I expect them to do. The issue was basically up in here somewhere. Yeah, instead of allocation flag none, it was doing committed, which means it gets one full texture page, which that'll be 64 megabytes for every texture, even small, tiny textures. But, you know, this sample doesn't have that many. I mean, the textures are all smaller than 64 megabytes for sure, because they're compressed and everything. It'll still use 64 megabytes of memory for them. So, all right, so if I start this up, let's see where we get. 1.6. Ended up looking about the same. That's funny. Yeah, not probably a great test. I can probably get some actual stats if I wanted to dig into the right API to get the actual stats. But I don't know. It doesn't seem worth it for this. Let me see. Let me see what the thing is. Let's see, what's the API for that? Okay, so it comes from the adapter query memory info. Do we even have the adapter? I think the adapter is in here. Yeah, there's our adapter. Even have the correct API in here. No, it's part of DGI Adapter 3. Question is, DGI Adapter 3, is that a, let's see where does the adapter meet the, I guess the adapter is part of the system. Oh, we don't even use an adapter on DX12, so that, or on Xbox, so wouldn't kind of apply to there. Also keep in mind, Cthulhu says, also keep in mind that we don't clear destruction queues until unit test teardown on most of these tests because we don't call %. So the behavior in the CI runner is also different in that aspect. Yeah, I mean, it definitely behaves differently because of stuff like that. And it does make me wonder, you know, I don't know, maybe that's okay that that's the case. But I think this will still, we'll test it. I'll submit a PR or push something in my PR to do a test for this. Anyways, I'm not going to dig further into trying to get the memory allocator to work, or the memory, or testing for the memory usage on the device to work, because it's a side track that I don't really need to mess with right now. I mean, I do think that it wouldn't be bad for MonoGame to eventually expose some sort of API that shows memory usage on your GPU and things like that. That would be nice. XNA really didn't have any way to tell those things, but it wouldn't be bad to have, I think, but not today. So I'm going with my gut at the moment. So let's do that. So instead of committed, I do want to do this though. One thing that's said about, you know, allocation committed versus none. Committed resource, contain resource will not have a heap, as the heap is implicit. Raw memory allocations. Okay. Allocations of its own dedicated memory location, committed resource with implicit heap used for special big resources like full screen textures as render targets. You know, and I see suggested that using it for things like that, specifically using it for things like swap change, is not a bad idea. So I think I want to at least make that change here. Is use it for the swap chain, just to kind of preserve that behavior. Because there's also some benefits. It doesn't, things from one heap can't interfere with another one. Or not from one heap, but from one page in this thing. So there's some benefit that things can't leak across to the swap chain. There's also some performance implications to it, that some device drivers can take advantage of the fact that the swap chain is on its own. It's on its own page. So I'm going to do that, and then in here I'm going to do so swap chain will always be committed resource memory, which I think is an improvement. There was also, so that's one thing I wanted to test. Before I do that though, I'm going to test, you know, just, I'm going to commit one test commit to see how the unit test runner runs it. Nope, wrong thing. There we go. Let's just commit this as a test, and we'll rewrite the commit later because we don't want to leave it that way. So I want to see if the unit test runner actually succeeds with this. It's in here, yeah. I'm going to leave that disabled. Let's see what the unit test runner does. Actually, you know what? There's one more thing I want to do before I test that. Yeah, because the other thing that's concerning is the other resource creation. Where is it? Is it in here? No, it's in here. These temp buffers. That's cleanup code. Is that occurring on? Okay, it does some cleanup. Evict old buffers that are too small. Yeah, I'm not sure about this code exactly. I looked at it close, basically just to see that it should work, and this is okay. I don't know if I love the idea of every time we allocate some textures, or allocate a temp texture, we destroy one as well. But I guess that can work. At a certain point, it puts pressure on it to reduce it. We should be keeping track of how long has this, since this has been used, and throw it away. Basically, if it's not been used in a while, this is okay for right now. But more importantly, yeah, this could probably be better, but it's good enough for right now. What I wanted to do was this. I don't think that, these are all temporary buffers used for copies. They probably don't need their own dedicated page, and it makes it like, if I go through here, you'll see that most of these that are coming through here are tiny. So it doesn't make sense for them to be on their own page. So I think I'm going to definitely force this to flag none, so that they're on separate pages, or they can be on one page instead of each having their own page. I think that's going to be better memory usage wise. It means that, like before, like here, let's just show you. Does this tell us? I thought this thing told me how much memory the alloc was using. I think it does. Yeah. Anyways, this I think needed to change to none. So here, what it's allocating here is 264 bytes, essentially. And if we allocated them with none, I believe it's just going to allocate a subsection of 264 bytes. Where does it put it? It's going to be in there, I think. It'll tell me what the... I'll also put this thing in the watch so we can see it. So, okay, but it has some alignment. So it's still allocating 65K. But it's not allocating a... wait. That's not 64. Am I getting that wrong? No, yeah, it's 64 megabytes, not 64 bytes. Yeah, just was coincidence that made me confused. Is that the actual... Here's the allocator. Just the minimum size based on the alignment, but it's 65K, so that's pretty tiny. It's pretty tiny for now. I'll mention this because it just reminds me, like, when I was a child, my father had a TRS-80, and we had to upgrade it because it didn't have enough memory. And we did a giant upgrade from 64 kilobytes to 128 kilobytes. It was a massive upgrade for our TRS-80. Could do so much more. And now we're talking about 65K on a 200 byte alignment. It's just, who cares? Anyways, so 65, and I think that's going to show accurately. Let's see what happens. So that for that tiny thing, let's see another one, 65K. What's the actual size? The actual size is here. another 264 bytes. There's that, so you can see all these are pretty small allocations overall, right? There's one that's actually kind of big. That's 4 megabytes. First one that was actually a reasonable size, and that's because it's loading a texture. Probably this background or this logo, something like that. So now let's look at it. If we put the, I'm sorry, not that. If we put this back to using committed, assume Sam, hey. So now we allocate. Alignment is 0, size is that, but what did it displace the thing? I was hoping to find like verification here. I'm not finding the hint that tells me exactly how much resources it's using. Preferred block size, yeah, we get that. That's telling me actual size, not how much it actually is using. Damn, I was hoping this was going to show me actually memory usage. That's annoying. So you just have to go with the theoretical instead of the seeing some actual data. I mean, it's probably deep inside of this thing. I could probably find it. It's probably inside the lock handle, like where it's actually at and how much memory it's actually wasting. You know. Yeah. So we don't want to do that. Oh, don't want to do that either. Assume Sam, was a TRS-80 one of those that didn't have a display? No, no, it had a display. It was one of these guys. Let's see if I can find the similar model to what I had. It was this guy. It was a Model 4 with the built-in disk drives. It was not. It was a little bit. It was more white than green. I think ours wasn't green, if I remember correctly, because there's one that was more like that color. It wasn't very green. I wonder why that was. Why did they sell them in 2 models? I guess. Because I'm pretty sure everything it displayed on ours was white. Here's a throwback. Oh, yes. That website's probably never... Oh, there it is. So this is the flight simulator was on it. It was sweet. It wasn't the SubLogic one. I'm pretty sure it was the Microsoft one, or maybe it was the SubLogic one. Man. That was a long time ago. I guess that was late 70s, early 80s, I guess. It could have been this. Try to see if I remember the... Nah, I don't think it was this one. But still, it's pretty fun. Wow. Anyways, yeah, fun stuff. Yeah, the 5.5-inch floppies. Yep, those are awesome. All right, so didn't get the information I needed, but we're gonna just use the the pooled allocations for this because they're temporary. They're just used for uploading and downloading stuff. There's no real performance benefit. We don't render from them or anything. I think this is better for memory usage than putting them into a dedicated allocation. And it'll probably have less cases of it, fragmenting memory and everything. With dedicated allocations, I'm a little bit worried about fragmentation and things like that. So yeah, that I think I'm going to test as well. So let's see. So we're going to test disabling this. Actually, let's put those two fixes in first. Nope. Oh, I forgot to commit that stuff. So we're going to use committed memory. And let's put in the other one. It's in here, right? Let me put a comment back here.
Frankly, my dear, I don't give a damn.
Just put a note of why I did it, so that somebody that comes around behind me can tell me why I did it wrong. There might be some more fixes to be do this for the same sort of thing in the regular. And this is something I need to fix at some point. It's not going to happen for this, but for 386, I want to do is I'm going to collapse all this code that's in these other contexts and everything. We're going to collapse all this garbage back into the single DX12 CPV file, just to match how we have it with Vulkan. Because it's just better for it to all be together instead of spread out everywhere, and I'm trying to dig and find files. Putting it together is simpler. A lot of engines work that way, including Godot, which, not that it's the best solution, but I find it more convenient for it to be all together. And there's a lot of just structure here that's unnecessary. You just duplicate stuff we're already doing, and it means that there's two systems for things. So here in particular, wanted to look at this. So what is this doing then? We're just not specifying something? What does it do in that case? I guess is it defaulting to none, or is it defaulting to garbage? Guess it's defaulting to none. It feels strangely like defaulting to garbage. That's interesting. I want to see what it does here. I mean, I know the curly brackets are kind of magic. They do something. Yeah, so there's a default. Is there a default constructor in here? Why is this getting default constructed to something? I don't understand. I mean, I guess it got cleared to empty because magic, because it decides curly brackets mean fill everything with zeros, which I guess is true. So I guess it defaults to none. So I just wanted to verify that this was not, being set to commit or something like that and stealing a bunch of memory. Occlusion query is set to commit. I don't know if that's a good thing or a bad thing. I want to double check that. Well, that's not freaking required, but yeah, that's kind of interesting. I wonder why it does that. I mean, he's creating a buffer. He's creating an 8-byte buffer and it's getting committed. That's probably bad. My guess is that's bad. I'm going to double check it though. I'm going to run I think we have a occlusionary test. We'll test that here in a little bit. So let me do it now because I'm going to forget otherwise, and then that's going to be a problem. Let's explore our unit test, graphics, occlusion query tests. I'm going to debug that. Let's let it hit the test. Returns a valid query. Succeeded or allocated the memory it needed to. I guess that's the size that it has to be for that. Anyway, so that's the memory check. Okay, so those all succeed. I just want to double check that if I move this to none, that it doesn't do anything mad. It doesn't like blow up or stop working. It works. So I'm going to keep with none. That's a tiny allocation. Sticking it into its own heap is fucking dumb. Buffer, new chunk for the ring buffer, right? That's probably fine too there. It's not, the ring buffer is a megabyte at a time, so it'll create more of them, but it's, it's a reasonable size for it to stick into thing. The ring buffer was a thing that kind of improved. It's kind of the same as the push buffer or the push buffers that we have in Vulkan. Let's see. So with that, let that run again here locally just to verify things are working. Keep going, unit tests. So we're going to commit a couple things here. I'm going to commit the things that I know we're keeping. I want to make sure that's at none. And do we have another one? No, I think that was the only other one I changed. Yeah. Yeah, that looks like it's going to be fine. Let's let it get to the threading test at least. I mean, I'm not totally convinced that there are not other issues in here. commit that. Let's push it. So pushing that up. So this thing should start building again, and we'll see if that succeeds or if it immediately blows up. I mean, it blew up pretty quickly last time too, so we'll double check that and see, because if it does, then we'll revert that, or we'll come up with something else. One technique that we can use if we just need it for the unit test, specifically because our unit test runner is not performing well under it. If it's required, then what we'll do is we can set an environment variable on the unit test runs, and internally inside of MonoGame, we check that environment variable, and if it exists, we can then set that to a lower value temporarily, until we get a real system to be able to find those things. I hate that it's not like that unit test machine is like complete garbage. It's okay. It should run fine. So this just must be the stress we're putting on the system because of the tests that we have. As you mentioned, it doesn't clean up resources until it, does present. So it might leak a bunch of stuff until present is called, which it just doesn't happen in some of those tests. I mean, we should consider whether we should run those cleanups more often than just in present to avoid this problem in other cases. It could just be that we want to run it, we have to come up with a heuristic of like when we run it. It could be that we also do it if we've detected present hasn't happened in a while, or something of that nature, because that stuff can kind of happen. Yeah, I mean, if this fails and we need to set it, I want to probably set an environment variable of some sort that we can then detect and fix it at the low level because of that. Yeah, the configuration service. Yeah, I think we should come up with something, and I think enums is the right approach, probably. It's just there's sometimes we need to make it. I'm a little concerned because there might be cases where we want to expose some of those configurations that are very platform specific, so we can't put them in public. That's why, there's a reason why, that's why this came about. Where is it? You look in, I guess it's in Effect Compiler. Yeah, it's in there somewhere. That's why shader profile works the way that it does. Shader profile has a name and a format ID, right? And then we predefine shader profiles for these different things. And it's like, well, why does this exist? Why isn't this an enum, for different types of shader profiles? Why isn't there an enum there? Well, because in enum, you can't use like the extend or the partial keyword on you can use partial to extend a class, right? Which we use to be able to turn on things optionally in different cases. But you can't use a partial on an enum, which is a little annoying, but I get why that is. So the reason why this works with strings is so that on console platforms where we can't share any of that code, we can have a defined shader profile that is only in the console code base, but this doesn't need to know about it, but it still works with it. That's why we did it this way with string IDs and not enums. So yeah, that's the reason why that happened that way. Anyways, we'll have to come up with some convention, to make that work that is flexible enough that if we wanted to add things that were specific to a specific platform, that we could do that in a nice way without it having to be hard-coded. But some validation wouldn't hurt, It could be that if you pass it a string that doesn't make sense, it validates and tells you, hey, you gave me something that wasn't handled. Maybe that's good enough, just alerting you to when you're doing it wrong. Anyways, so did my unit tests finish? Yep, they did. So unit tests are all good. I wanted to look at what was happening there a second ago. Or waiting for the other tests to finish running. Still building things. when we ran, and we'll just use the query. Actually, yeah, I mean, this doesn't use a lot of resources, so let's just run that. Or sort of, that's an interesting thought, but how would the compiler know what order to put the members between partials in order? Yeah, exactly. That's the confusion. It's like, well, how does it know how to connect things? And, yeah, if there's not a really good solution to that, it's a design problem, and they couldn't come up with a simple, effective, natural concept for it to work. So it just doesn't support it. All right, so I wanted to see this. The most important assert in the entire library, I've disabled this before. Hitting it means you have some memory leak. So we have a memory leak, and this is just running in a unit test. So I want to figure out what this is and fix it. It's not critical. Again, most games, when your process shutdowns, it just releases everything. You're not leaking graphics resources onto the GPU or anything. It'll go away and get cleaned up. It's just annoying that we have this leak. Build step takes 20 plus minutes or so on the Windows and Mac build runners. Yeah, it's slow. If we had a better budget, we would pay for better runners potentially, but we don't have a better budget, so we're living under the budgets that we have. So I think the fixes that were done a couple weeks ago on the unit test runners, I think Cthulhu Lover, you did that work, I think. Definitely help things. More efficient use of our build runners would be good, but we have more tests we need to run. That's the biggest thing, is we just have more tests to run. Let's see. Sorry, I got distracted. All right, so let's figure out what this asset is. That's the thing I wanted to learn, is why is this failing? Is this going to continue? No, it's going to fail. It's going to give me some leak information. I mean, this is just a regular leak. It's not even that leak. This will help us though. So 794, let's see if it's consistent. I think it'll show up in here. Will it? No, it's not gonna. I have to actually run it and yeah, I have to run it as debugger again. 794 it was before. Let's see what it is this time. Okay, it's consistent. Good. So that means I can come in here. Basically, the trick for that is, and whatever this leak is, it's not. I don't think it's related to the GPU leak. This will tell us exactly where the issue is. So if I come in here to Windows DX and I come to, it's going to be, the code is actually in the SDL side. It's in the platform code. See this thing? So in platform create, put that sucker in there, and it will now break when this allocation 794 goes off. Oh, damn it. That's not what I wanted. Sorry, hit F5. So used to doing that. So I'm gonna hit debug. All right, so there's the break. What was being allocated? Is buffer destroy was allocating? Oh, it's pushing it onto the destroy list. Interesting. So this isn't freed? That's the internal destroy list isn't being freed. Is that true? Yeah, that can't be true. Yeah, I thought that went through. It's interesting though that it's that allocation. I mean, it's reallocating the queue here. It's going to add something more to it. It is a queue. Or it's allocating, I guess, a node within that queue, I guess. Stop debugging. Let's go back and disable that real quick. I mean, this is not like super important, but I kind of want to just finish this stuff and get it working properly, completely. Okay, so he's destroying the graphics device. It's going to destroy everything. Oh, wait a second. Is this a side effect that... I mean, those queues exist still. They're empty, so it's not that they're not empty, which didn't make sense. Destroys the samplers, destroys this. I think I know what's going on here. Does that. This is it saying, hey, it lost that, and I bet when it does that, okay, that's why it was leaking. Those leaks are just side effects of the fact that it didn't get a chance to delete the device. This didn't get called. If I hit F5, that doesn't get called. That's what those leaks are. It has nothing to do with any of this bullshit. It just has to do with that assert. Okay, so that's nothing. I still need to find what that actual leaked asset is, that resource. And unfortunately, I don't think this memory allocator, I don't think it has anything to tell us what the fucking leak is. Let's double check. I'm gonna run it again. Still building Windows. Okay, nope, not you. Okay, well that tells us something. It's 6 megabytes. I mean, that suggests a bigger resource. I mean, is it like the ring buffer maybe? No, because it's like a megabyte size. Does this have a name associated to it? This is why everything needs to have names associated to it. Doesn't this actually put a name on the allocation? But it has a name. Where is it? So you can give this thing a name because it's supposed to show up in here. I could have sworn that this is supposed to have a name. Maybe a step further out. I can't get much lower than this. Well, it doesn't tell me very much. Let's double check some stuff. I mean, we're freeing the temp textures, right? We should be. I mean, and that gets freed inside of it's gonna be freed inside of the resources, I'm pretty sure, if I remember correctly. Okay, temp buffers have com pointers, and this clear should cause them all to be freed. I'm going to get rid of this transient buffer. This transient buffer was sort of like the push buffer that was there before, but had a problem in that it was a fixed size. And it's like, oh, just make it bigger if you run out. It's like, well, that doesn't really work very well. I just want to verify that this is actually freeing memory. It should. I sometimes just don't trust that destructors on STL vectors do the right thing. So there's 2 temp buffers in here. What sizes are they? Small. Small. So it shouldn't be that, but we will see. What I wanted to do was put a breakpoint up in here. I mean, I guess it's not going to necessarily call that. It would call the memory free. Oh, stream boo. Block stream boo. Goodbye, stream boo. We hardly knew ye. What else is in here that's not getting freed potentially? Okay, read buffer is a member. You know what? This isn't. This is definitely not being freed. I mean, it is being freed, but it's being freed late, right? Because it's going to be freed when this happens, but resources are being freed there. So that's kind of a problem. So let's fix that. It might be the source of the problem. We'll see. And what I can do is, this might be the easier way to do it, potentially. Just as a test. See if that order fixes things. I'm going to take a look real quick at the ring buffer. He has 1 chunk. Not a lot of memory, but it is something that's being leaked. Still hitting. Still a big chunk of memory. Not like free. What is it not freeing? Well, we know what size it is, right? So we should be able to go up here. Come on, thing, stop. Come on. Still trying to build Windows. Unit test runner, that is. See if I can find the allocation. There shouldn't be that many allocations in this unit test. I say that. Could be completely wrong. Where's it actually do? Let's step into where it actually does the allocation. There's an inner allocation call in here somewhere. Okay. That's what we're looking for. Hopefully there's not too many of those. What? No, it must have been allocated first. You know, I probably should have done that in a different place. That's probably the wrong place to test that. Should have probably done it deeper in an allocation routine. Yeah. All right, guys. Come on. Let's do this right. That was the wrong place to do that. I find conditional breakpoints can kind of be very annoying to figure out. Sometimes when I'm working on that stuff, I will. You know, it's not coming from there, so let's find all references of that. Oh, great. Of course, there's not a centralized place where it all goes through. I mean, it probably is actually create place resource. That probably is the same on all these. Or not. Yeah, whatever. Just put a breakpoint on all these. And then the ones that hit, we'll add the. No, that's not one of them. Which is this one, and this one. Damn it. So used to hitting a 5. God, yeah. Yeah. All right, so it never hits that allocation size. Seems to think it did. Fuck you. I'm gonna do this. Nope, I don't want to do that. It's gotta get there. That's gotta hit, right? What happened to my other tab? I guess oh, it's still running, that's why. It's gotta hit that now. Unless something's cheating. Ugh. Like something like this, you'd think that there would be a very easy way to debug this issue. What did it do? Did it inline this or something? Oh God, it's doing this bullshit. It's showing me every single place the word init is used. It's like Visual Studio is so dumb. At least with C++, you right click on this, it's like find all references. It's not finding all references, it's finding all copies of this string. It's so fucking stupid. Interesting. Still trying to chase this bug down, or this leak down. This might get us further, maybe. At least there we can actually set a breakpoint. All right, if this gets me to where I want to be, I don't care. I just want this to work so I can solve this leak and be done with it. Like just running this causes a leak, that's kind of bad. I'm sure it's something dumb. Hey, look, there it is right there. That's the size. What is it creating? Command context. It's creating a command context that's not getting cleaned up. Interesting. How many of those are we creating? Well, there's command context being cleared. Someone replacing that and not is this getting called multiple times or anything? Maybe there's more than one thing that does this. I think that's the same thing, right? I don't think it actually got out of here. It's still part of the same chain of allocations. God damn it. Diagnostics tools, I don't want you. I've never needed you. Okay. Just wanted to verify that there isn't like another one. This might hit a lot of times. I kind of want to be thorough and find this shit. Oh, is it within command context itself? It's creating a... There's a lock there. No, that it. I mean, it's an array of these guys. Those should free. So much recursive code. Topic change. What's the time, sir? I'm from Romania. It is 3:25 p.m. 3:25 in the afternoon. Okay, let's be very explicit about things up here. Hey, the Windows tests. I mean, the Mac and the Linux tests passed. The Windows tests are still running. So finally it's gotten to that. I mean, this should definitely be cleared, but I want to make sure. What's the right way to do that? God, I hate these fucking style brackets. The worst. We're using 3 back buffers by default. Okay. We can. Just curious why we're at 3 back buffers. I mean, I guess it's still using 2, but it's, typically we haven't done that in MonoGame in the past, but that's fine. I think Vulkan's doing the same thing, but it's also something we should probably expose. Stem textures are getting freed. Another wacky system that's in there separate from everything else. So a bunch of different pool systems that we can probably unify. All right. I'm just gonna do. Yeah, let's do it like this. I think reset specifically. I think that's how that works. Reset is release. Internal release, yeah. Assuming that actually will release it. What else is in there that's there's that guy, this guy. Probably do the resource first, huh? And when it runs this, I'm going to specifically walk through the damn thing and make sure it's actually releasing it, because I don't trust it. Oh no, the Windows test broke. Let's see. Is it the same issue? Whoop. Looks like it. Let's see. Failed to create graphics device. This is all the same thing. Fatal error with H result that. I think that was the interesting that it kept. It showed something different. That's interesting. Out of memory. Yep. So it's the second that that other thing was turned on, out of memory. It just does not like 64-bit or 64 megabyte default sizes for that. Which, what was his graphics device there? I mean, it could also be this the type of unit test is running, but I can't imagine why would it be failing. What was the? What is the memory usage on that guy? I mean, it's got 8 gigabytes of dedicated memory. I mean, it just seems kind of crazy that it's running out of memory. Yeah, GTX 1080, I mean, that's an older card, but it's running out of 8. It has 8 gigabytes of memory. It shouldn't be running out. Why is it running out? I mean, the unit, none of the tests are like allocate a 4096 texture a million times. It's the address space. It's a 32-bit machine? Wait, it's a 32-bit machine? I didn't notice that. No, it's a 64-bit machine. What's the address? I don't understand what the address space issue is then. Well, that is annoying. I'm just gonna turn it down a little bit and see if that'll fix it. Go down to 32 megabytes. And that might be good enough for right now. Okay, so. 0, it's releasing the memory. I thought at one point you could actually look at the reference counts for these things. Maybe I'm thinking of something else. Fucker. So annoying when that happens. Precise clicking. Yeah, it is. Still, same freaking thing. I mean, I guess that unit, but it isn't that specific test, is it? I mean, so Cthulhu was discussing with me in chat here what's happening. I mean, they're not calling present, but it's tearing down the device between tests. And like, if I go back to the results here, put in another window here real quick. I mean, I guess this isn't in linear order or something. Like, it's giving me a bunch of error results. I assume those are associated to everything that failed below. Threading test background loading. Okay, so that one could be a memory error, right? Text cube test. You know, if that's the same, I assume that's the same out of memory error. Well, why would it be out of memory in this test? Are we saying that the failure of this test failed that test? But I think it destroys I would think that between different fixtures, it's destroying the graphics device and recreating it. So it should be releasing those things. I think. What does that say? Oh, that's weird. So yeah, I mean, I think that's kind of weird. Why would it do that? I mean, I guess it's possible. I mean, I also wonder why this test is the first one it showed. I mean, is it running all the tests in parallel at the same time? Is that what's happening? I mean, it's not running all the tests in parallel, is it? Because that would be insanity. That's the only other thing I can think of. Like, why is this happen to be the first error it shows up when it's, you know, at least when I look at the unit tests here, you know, the unit test is way down in the list of unit tests. Why would it be running it? Why would it show up as the first error by chance out of all the tests that are in here? You know, there are 400 tests. By chance, it happened to pick this one to run first. That seems kind of weird. But I do really wonder if it's trying to run all these tests in parallel. I mean, does it do that? I mean, I guess if it crashes the driver, things can flip out. I don't know. It just seems like a really weird result. I'm disappointed because it should just work. I guess what we can do is I mean, I guess if we want to do it the cleaner way, we want to set an environment variable, but I don't want to mess with all this junk to fix it. We want to pass a hint down to it. Ideally, we can pass it from the unit test framework itself somehow. Where's our tests part of this here? There. I wonder if I can. Is there any code in here that? I mean, is it actually running the program? No, it's the runner's running it. The program is actually running, so it can't be there. I'm just thinking of a place that we can set the environment variable from C# code and make sure that it runs. Pretty certain this is not going to get run. I will test this thing I was already on. I just don't know if there's an entry point that I know is run on every test. And I guess I could. Have some attributes that it calls. And I guess I can put it in here potentially. Yeah. Like I think if I do, this might be the worst thing to do, but who knows? I wonder if I do that, can I then down in, where is it, in here? Yeah. I'm wondering if I can read it there. I guess I can use that old thing. Feels old and dusty, but when we're messing with environment variables, it feels old and dusty. What's our path? Come on, thing. I think they'll return null if it's, what's their doc on that? CPP reference, I love it. No such variables found. I just don't care what if it exists, it exists, I guess. We just look for existence. We don't care what the value is. Let's see if this magic works. Make sure it hits that too. Okay, it does that. Hey, look at that. So that works. I mean, it's super gross. I hate it, but it works. And I guess this could be replaced eventually with that configuration thing. Is this the only place where we create a graphics device manager in the unit tests? There's some other places that do it. And I could do it maybe in game test space or something. Something that's called every time we start a test. Yeah, I think game test space is called for everything that uses graphics. So I'm going to put it inside of there. Then at least I know it'll get called everywhere. I'll add a note. And at least we don't have this pain on that case. So that'll look there. And then, where was I? Resources, right. What was really annoying is that we don't have this problem in Vulkan, which doesn't make any sense to me. Why is it only failing on DX12? It's not like the Vulkan unit tests use significantly less memory. Like, why would it be? It's still baffling to me. Anyways, rant off. Yeah, I don't know how we would get an actual memory dump on it. But at least we know that this fixes it, and it only deals, solves it at least for that. All right, let's push that so we can start building. Yeah, I mean, if you have some recommendations, what do you think we should do to get a good memory usage information, I guess. I mean, I guess knowing, I mean, you know, I started the stream thinking like, oh, I need to know how much memory DX12 is using. Maybe I should actually figure that out, you know. What is this junk? Old garbage. It's interesting. Are those things still on our repo? Oh, yeah. Why is this still on our repo? We haven't used Team City in forever, right? We should probably kill this folder. Somebody. Hey, at least we moved the UIA references 6 years ago. Somebody gets a chance to submit a pull request for that. That probably wouldn't be bad. I don't think that we need any of those things. All right, so with this, where was I? I have more things to push, but let's get this resolved first, or get the unit test running first. So where is it? Nope. There we go. Oh wait, that's the one I want to remove. Game base. Fuck, I did one of those fucking around with the strings. We talked about it a little bit internally. We're going to do a big, massive cleanup of all the formatting in the project after 3.8.5 is out the door. It's going to be a giant Band-Aid rip. All right, so and amend that last commit, and I'll just force push it. Thing should start running our tests again. I lost my window for that. All right, so that at least won't affect anything else. I guess I'll double check this is actually happening here. I'm gonna go back to Yaris Turtle. If you want to clean up that directory, that'd be good. Or I guess if you put the issue in, at least somebody will attack it. Hopefully somebody will. Oh wait, what is happening here? Wait, what happened? What did I get wrong here? What went wrong here? I don't understand. I just ran this and it worked. What happened? I mean, I changed something, but I didn't run it again, which I probably should have, but why didn't it work? should have hit this first. Why is it suddenly not working? I don't understand. I just did it and it did work. What's magical about this thing? What the frick did I break? It just worked. I don't understand. This code must be wrong somehow. I mean, I don't understand. I just ran it and it worked. Why did it stop working? I mean, it worked the first time. Why did it fail after that? Sometimes it's baffling to me why these things happen. Can I do like, now, what is it? I mean, I moved it. I just tested that it's being set. I'm literally stepping through the code that set it. I mean, I guess you guys are delayed to me. Jane makes games. Hello. I moved the code, but I didn't change the code. It's still being called. I mean, I didn't realize that. Is having the environment call in a different function that also is being called before it creates the device change the effect? I mean, that doesn't seem to be the problem or a problem. I mean, the code used to be in here. I moved it from, like, if I undo, there it is there. I moved it and set it inside of here. It's the same code. It's also in here. So I'm setting it twice now, inside there and inside it and outside of here. I don't know why this would be different than down there, or down in this would be different than inside of this function. It creates the graphics device there. Now it sees it. Why would that be different? I don't understand it. I don't understand. Why? Why is it here? It works. But inside of here, it doesn't. What magical bullshit. I don't understand. Why would that... This must be... I mean, it's C#. It's not like, oh, it didn't rebuild the code or something. I mean, it must have just not built the code. That's got to be what it is. I put some... I changed the code around a little bit. Maybe just, you know, because I did it. I mean, breakpoint there. Hit debug, it's going to build it again. Look, it set it. Now it's not there. What the fuck? I don't understand. Why would this be? Why is it putting it in the exact place that I want? I mean, but the native code... Wait, is it because of when the native code... Okay, wait a second. Is it because... I mean, I thought that the environment, it's getting it from the OS. It's not being passed into the system, but the native code might have been started up. But isn't it execution that matters? Not that the native library was loaded? Or is it whenever the native DLL is being loaded, I guess at that point it makes a copy of the environment? Maybe? Because like, if I put a breakpoint in, yeah, because I know what you're trying to say now. What you're trying to say is that this code has already been called. I guess maybe when it loads the DLL, it's not sharing the environment. They're two separate environments. I guess that makes sense. Yeah, like if I debug this now, it's going to call this. Then it's going to set environment, then it's going to load the DLL, or it's going to call this first, then it's going to set the environment variable, and I bet that's what's happening. I was thinking the environment is shared between both systems, but it's not. So like here, so it's loaded the environment already up here. It hasn't even gotten there yet, because it's whenever I do this, this is when this is the first call that it makes to the platform is this. And I guess when it does this, it must copy the environment state at that point. It gets copied from C# to native code. And then it's using its own copy of the environment at that point. So yeah, well, I forgot that it does that it makes it copy the environment. Is there another place I can shove this maybe?
I don't give a damn.
That's annoying because that's like the best place to put it. I know another thing I could do. I know another thing I could do that would definitely cause it to happen. I have a better fix. Or not, I don't know about a better fix, but a fix. Come on, stop there. That will be called before it calls the constructor. It'll ensure this is called before it loads the DLL. At least for things that use test game base. Hopefully that's right for everything. So first time somebody touches test game base, it'll call this. So it's going to have to call it before it loads the native code. That's annoying though. I could have sworn this would have done the right thing, but now I get why it was happening. But at first it looked baffling. I mean, I could put this really anywhere. I was just trying to find the first place that would actually use it. But we know that for all the graphics tests, it has to create a test game base first. So now it's going to work. Okay. Still have my leak, but at least, you know. All right. Well, that's annoying. Just crossing the I's and dotting the T's here. Where did I do that? Oh, that's up in here. I hate submitting a bunch of PRs that are broken. I'd rather amend my commit. All right. So that works. Let me just, shits and giggles, I'm just going to run that and make sure it doesn't. It's going to set the state one time, but it should be only loading the native code one time. Like if it's running all the unit tests, 'cause it's running it in one instance, so it should be fine. Oh, the fixture base class, it's not a bad idea. That's okay, I already submitted. It's fine. It's not the end of the world. But you're right. The fixture base class is really like the. But do we use the fixture base class on all tests? What is it derived from, damn it? Where's the other half of this abstract? I mean, does it not have a test, an actual base class to this base class? I guess this is the lowest level thing for this test, I guess. Anyways. Yeah, I mean, I could have probably put it in here. Didn't think about that. Yeah, I'll fix it one more time. I mean, there are no other graphics tests that don't use the graphics device test fixture base class. Base. I assume there isn't. Yeah, I guess it's the only. I guess it has its own tests, but yeah, but I'm worried if it gets called, like if for whatever reason you're running a unit test and it calls this one first, it's not going to initialize it because it's not going to get called. Right, like if you're running up all the unit tests, it's not going to work right. So that's the problem, I think. This is still problematic. It might work for our current setup because we call graphics device tests altogether. If you're running a regular test from like F5, it's going to initialize this. Like if I do, if I set a breakpoint here, wait, no, not in here. Set a breakpoint in. Everything's always so complex, isn't it? If I set a breakpoint in here and then just hit F5, it's going to hit the audio tests. So it's doing the audio test. It hasn't hit that yet. So it loaded the native code, but it did not call that. It didn't set this up yet. I just don't know if there's a singular thing that does this everywhere. I guess I just have to. I mean, but this should work for at least the case of. Yeah, so I don't know. Hello, watching. Hello, Maxim Tech. I mean, this is probably better. There's just not one thing that gets called in all cases that is part of the test system is called in before every single test, I don't think. I mean, I guess I could do something really stupid and tricky, like stick it on an attribute that we use. Guess that might force it, right? I don't know. I'm going to try this. This is slightly better than what I just did. Because at least it's in a better place here. I'm watching my smartphone. This is impossible. Read code lol, just watching PC. Okay, sure. Okay, I'm going to push that as another update. We'll just restart the tests. Hopefully that'll get it past those things. Yeah, I guess I didn't really... I mean, my code's been at a higher size for a while now. You guys made me start using bigger text, not just because my eyes are getting worse because I'm aging and decaying, but also because for the stream. But yeah, possibly some of this is probably really small to see on a phone screen, which sucks. All right, well, this might have to be it for the day, which sucks. I was hoping to get more done, but we got through some stuff, I guess. If you get a chance to look at the Vulkan issues we're having at Ascent, this should still work. Let me double check this real quick while we're here thinking of this. I'm probably going to push a couple more of these things. I have some more testing to do. The project I can't talk about, it has some problems relating to threading and this stuff. And this, I'm going to test some things there to verify that it improved things. But there was having a problem there that might actually be a problem in the main repository as well. So I wanted to double check that. Where was this? There it is. So I wanted to double check that this wasn't executing at all here. I still want to know why Vulkan is fine, but DX12 isn't. Still baffling to me why that is, because it totally should work the same, have the same limitations. That said, startup time here is super fast. Well, debug build. That's super fast, you know, compared to the Vulkan startup time. So there's still something really wrong with Vulkan on texture loading. But I think everything is good enough to ship. So 385 can go out the door. Assuming that this unit test passes after this, I think I'm going to commit a couple more things, but I'm going to see if we can make some new preview builds for 385, so that we can kind of get the preview builds out there, have them sync, have everybody get a chance to mess with them over the week, you know, and then we should know. There's that same leak at the end here, which is that the same size? It's that same fucking size. So we've been running the full game. So there's something, this big size that's getting allocated that's not being freed. And it's in common code. It's not game specific code. God damn, I'm going to find what that is. Yeah, Vulkan loading speed we can tackle later. So, all right, everybody. So did we learn anything? Maybe, I guess. Maybe we did. I guess what we learned is, for some reason, our DX12 implementation is using more memory than it should be for some reason. A lot more memory, at least in the test, than Vulkan is. Vulkan starts up slowly, or it has performance issues loading textures, which we need to look into. Yeah, it could be the test not cleaning up when teardown happens. That said, I have this leak of a 6 megabyte leak, it seems, on every test. Who knows if that's causing problems? I guess, I mean, when the unit tests run, they run as one process, right? So the graphics unit tests all run as one process. So that process does not completely tear down and free any of its leaked memory until it gets completely done. It might allocate the graphics device and free it over and over again, right? And initialize the... No, actually, it should be creating... Yeah, I guess it starts up the native system one time. Now, it does create the platform code and destroy it several times, and it does create the graphics device and destroy it several times. So it's really putting stress tests on that path. But it doesn't free the actual native code itself. The DLL is not unloaded or anything. So anything it leaks continues to stay around across all the tests. So yeah, it seems like whatever. I'm going to keep chasing this leak here after the stream, but I have some other stuff to do too. So I got to get out of here. All right, guys, I appreciate you hanging out as always. Make sure you watch us on Twitch and YouTube. We're always trying to get our viewers up there. What's our Twitch count right now? One day we'll be popular on Twitch. One day. Just don't know when that day will be. Where are we at? 118 followers on Twitch. It's been a while since we've had a new follower on Twitch. We need more followers on Twitch. Also, MonoGame runs by donations. Your donations go directly towards helping the project, in particular, getting tasks like this done. It takes some time and effort to do that. Also, donation is not just money. It also means just your time and your energy. Taking a look at our current issues that are up on GitHub. If you see an issue that you know how to fix, submitting a pull request for that helps. Just spreading the word or testing our releases, that helps too. Everything's helpful. So, all right, guys, thanks for this week. I will see you guys again in a couple of weeks here when we have our next open hours. We have some cool stuff to talk about. All right, later, guys. Bye.